yeah. Yeah. Okay, done. Okay. So if you try to remember, we are solving some Neyman Pearson problem, and the probability of false alarm is given as this one. So if I'm not wrong, this is a lecture 09, and
So screen is not yet shared. So.
thank you. Your entire screen. Share. Hide. Yeah. So this is lecture 09 and 13th October 2020. I would like to use this. And Jason, I think I started recording the meeting. Yeah, it is being recorded now. Yeah. So we are trying to solve this problem. This is example problem which states that S is equals 0 and S is equals to 1. Noise is indicated as a 0 min and 1 variance. The probability of false alarm is given as a 10 to the power minus 3. So as I told you, the right tail probability, what was indicated in this shade, this is called right tail probability. Oh my god. Right. I really don't understand why it will be so slow. GHT, right tail probability. Technically, we'll call this as Q function. Q function. So as I have written over here, Q of y, Q of gamma. Q of gamma is something like a integral. Oh, it will be good if I try to close this. I'll just close this and open it once again. Q of gamma is equals to actually this is one of the biggest problem with this. Microsoft Word. Yeah, we were here. Yeah, the Q function Q of gamma can be written as integral gamma to infinity. Whatever the probability density function that you would like to have, for suppose if I would like to calculate the right tail probability of the Gauss, you can write a probability of fx of x. Let me write fx of x dx. In place of this fx of x, you can use either this one or this one. I don't have any problem. So for any Gaussian distribution, the Q function, actually this Q function is defined for a random variable x which follows normal distribution with a mean 0 and variance 1. So for this particular random variable, for this particular random variable, if you would like to calculate the right tail probability, this is if I consider this as gamma, and if I would like to calculate this area, you can make use of this Q function. Okay, so for suppose if I have a random variable y, which follows, if I have a random variable y, which follows a normal distribution with mean mu and variance sigma square, with mean mu and variance sigma square. If I have this random variable, then you can able to prove it very easily. The right tail probability for this random variable, right tail probability, right tail probability means now instead of having the mean at 0, it is going to have somewhere over here with mean mu y, and of course the variance, the spread is going to be given by sigma. In such situations, you can able to write in terms of this as right tail probability is equals to q of gamma minus mu, gamma minus mu divided by sigma, gamma minus mu divided by sigma. Okay, so you can prove this very easily. If a random variable x which is going to have a standard normal distribution with a mean 0 and variance 1, then the right tail probability is going to be given by the q function. Q of gamma is equals to q of gamma. You can try to make use of this equation. You can make use of this equation. Now if I try to have a random variable with a mean mu and variance sigma, then if at all you would like to calculate, that means whatever the values that you're going to get from here, from this particular integration, that we have to equate it to gamma minus mu divided by sigma. Okay, so if I try to equate it to this, then whatever the value that you are going to get for gamma, that is your actual threshold. We will try to take one example. Okay, no need to worry about this thing. And the very first thing what I would like to do now is I'll try to link this q function value with the probability of false alarm. Actually, if this probability of false alarm, what you are going to have over here is the right tail probability. Right tail probability of standard normal distribution with mean 0 and variance 1. Okay, so that is nothing but the area under this curve. So you can straight away say that actually q of gamma is the probability of false alarm. Q of gamma is the probability of false alarm. So the area under this curve from gamma to infinity will be giving you the probability of false alarm 10 to the power of minus 3. Now what value of gamma I should take so that my probability of false alarm, which is nothing but the q function, goes to 10 to the power of minus 3, so that you can able to assess it from the q function tables, q tables, q distributions. I hope you are following what I am saying. What I would like to know over here is what value of gamma, what value of this gamma will gives me the probability of false alarm, or the shaded area, yellow shaded area, equals to 10 to the power of minus 3. For that, I believe I have shared with you a probability distribution tables. I'll just open it for you. So this is the q function distribution, right tail probabilities. So right tail probability x is more or less similar to that of gamma. That means x is nothing but our threshold. I mean to say that this gamma is nothing but Rx. So what value of x will gives me the probability of false alarm 10 to the power of minus 3, that is 0.001. So this figure what I have shown to you, it is from the textbook Hippenstall. From this textbook I have taken this, and he has given the limited values, so you can be able to check it out. So if I try to take the value of x as some 1.6 over here, 1.6, if I take, okay, I think I cannot able to write here. So for suppose I would like to find out the right tail probability for a value of x 1.63. 1.63 means you can have a look on this. Here is somewhere over here 1.6, and then 1.6 0.03 is there. So 1.63 right tail probability will be 0.0516. I hope you understand what I am saying. 0.0516 is the value of the right tail probability or the q function for the value of gamma or x, which is equals to 1.63. So likewise, you can able to calculate the right tail probability or q function distribution for a value of x or gamma, which is equals to 2.27. Let me assume 2.27. 2.27 will be somewhere over here, and you are going to have 0.0088. Now, what value of x will be giving me the probability of false alarm 10 to the power of minus 3, which is equals to 0.001. So for that, I would like to find out the value in this particular chart, 0.001, because the probability of false alarm is given, and we would like to find out what is the value of x corresponding to the probability of false alarm 0.001, because 0.001 is the value that was given in the problem. So if I try to look into this whole So if you have a look over here, so this is 0.0014, 0.0014, 0.0015. So I believe this is the only value that I can able to have from this distribution. If you are supposed to finalize 0.0014 is the value which is nearer to or 10 to the power minus 3, which is equals to 0.001. So that means the value of the x or the value of gamma that will gives me the probability of false alarm, I can able to finalize it as 2.99, which is equals to 0.0014. So if you are given with such tables, this is the way how you are supposed to look into the distributions. Actually, this is called the Q function table, Q function distribution. Okay, so now I'll try to show you one more PDF. So that PDF is I believe it is here. The PDF is over here. Here straight away it was given over here. This I have downloaded from some website. So if you are provided with such tables, then you can able to have x value and q of x value. Straight away it was mentioned over here, x value and q of x value. As I told you, the probability of false alarm is nothing but the right tail probability and q of x. So q of x is equal to 10 to the power minus 3. So that means 0.001. So try to find out where 0.001 comes into picture. You see here 0.00013. So I can take 3.05 also for that matter. So but in the textbook, it was given as 3. In SMK textbook, the example which we have considered it as 3. So this is the way how to find out and how to calculate this Q function value or right tail probability in MATLAB. So here MATLAB is also readily available. So somehow these images were like that since a long time. So anyway, let me remove this. CLOS equals ALLR, enter. Okay, so CLEAR, enter, and CLC. Okay, now I would like to say one more thing over here. This Q function, let me go over here. So the Q function, Q of x, yeah, Q function, Q of gamma is more or less linked to complementary error function, ERFC. Okay, and complementary error function also you will try to do the integration in this particular complementary error function. Also you will be having the integral some constant to some infinity. This is it's a function similar to that of your Q function you will be having. If you are very good at complementary error functions and error functions, ERF and ERFC, it will be very good. You can able to assess this problem very easily. Okay, the reason why I am saying this thing is particularly in this particular MATLAB, Q of gamma can be written as 1 by 2 times complementary error function of gamma by √2. This is the relation what you are going to have. Okay, and actually this error function ERFC is the inbuilt MATLAB command. I'll try to do one thing, because Q of gamma, see actually complementary error function, yeah, I'll try to show it to you for a while. This is equals to 10 to the power of minus 3 that was given in the problem. So what value of gamma will gives me the probability of false alarm 10 to the power of minus 3? That you can straight away do it using your MATLAB. You try to remember this equation, 1 by 2 times a complementary error function of gamma by √2. Okay, there is no minus over there. So I'll try to do it over here. Okay, so if I try to do it over here, yeah, now what I'll try to do, I would like to find out the value of gamma. I would like to calculate the value of gamma, for which the probability of false alarm is 10 to the power of minus 3. Okay, so for that what I'll try to do is x is equals to because there is a multiplication factor of 0.5 at the beginning. 1 by 2. So I'll try to multiply this with 0.5, and then where is this star? Star. Okay. ERFC ERFC of ERFC of ERFC of 0.0001 divided by square root SQRT 2. I believe this will be giving you the value of the gamma. So this is not 3, right? Huh. So this is right. If I'm not wrong, this is right. So what I would like you people to do is you multiply the answer with 0.449. Okay, let me do this thing. X multiplied with SQRT of 2. Something wrong has been occurred here. Something wrong has been occurred. Yeah, let me check this thing. Oh, yeah, come here. So if I am not wrong, you see here 0. Complementary error function and error function. Okay. Just a second. Yeah, let me go down.
Sir, in place of gamma, you have substituted 0.001, sir.
Did you understand what I have done? See, actually, the gamma value I have taken as 3. When I take the gamma value, then whatever the x that I'm going to get over here, it is a q function of x. Okay. So the other way, if you would like to do, then you should go for a with error function. Okay. Error function. Yeah, I'll tell you what is that error function. I'll try to write the command also for you so that you don't find. Yeah. Now what I'll try to do is enter. So x is equals to, or let me consider y is equals to SQRT of 2 multiplied with yeah, shift. I don't think this will work if I'm not wrong. Shift ERF INV shift 1 minus 2 into 0.001 10 to the power minus 3 shift. So 1, I think 1 is sufficient, right? Yeah, 1 is sufficient. 3.09. Okay. So actually there is a inverse error function. Okay. see the reason why I have multiplied with a square root of 2, you might have understood.
Sir,
Yeah,
sir,
please.
screen sharing is stopped, sir.
Screen sharing is
Stopped.
entire screen. Okay. So yeah, let me come over here again. Yeah. As I told you, this right tail probability is going to be indicated with Q of gamma, and this is linked with complementary error function, and that's what I have written over here if I'm not wrong. Okay, so if the right tail probability is given with in terms of the complementary error function using these terms, then 1 minus complementary error function of gamma will be is equals to error function of gamma, which means that earlier you have taken the integration from gamma to infinity, this area. Now 1 minus this area, if I try to remove, I'll be getting the area of this portion, that is going to be given with error function of gamma. Okay, so error function of gamma will be, so more or less if you try to look into this, error function of gamma is linked with CDF, cumulative distribution function. Error function of gamma is linked with cumulative distribution function. So I just want you people to have a look on the plots of Q function, error function, and ERF and complementary error function. Complementary in the sense 1 minus error function will be given the complementary error function. Actually, error function is going to be defined, if I'm not wrong, error function of, yeah, could you please stay for a while? Okay, I'm sorry. So error function is going to be defined as, if I'm not wrong, 1 upon root 2 pi integral minus infinity to some, yeah, what happened to this? Integral minus infinity to some x. If I would like to calculate error function of x, exponential of minus x square by 2 dx. This is error function definition. Forget about this constant and constant parameter. If you try to look into this, this is a standard normal distribution with mean 0 and variance 1, and the integration has been gone from minus infinity to x, minus infinity to plus x. Okay, if you want, I can put here gamma so that this will not get overlapped with this x over here. The x here, it is a dummy variable. So error function is equivalent to, or to that matter, error function, it is related to CDF. Error function ERF is related to CDF, complementary cumulative distribution function. And complementary error function is linked with Q of x, Q function, Q distribution. And if at all you would like to know, this ERF is equals to 1 minus ERFC. Okay, ERF is equals to 1 minus ERFC. Okay, this is just a simple mathematical background that you are supposed to have, nothing more than that. So why I have told all these things is you are supposed to learn some fundamentals related to this, and you should know how to at least look into these distributions. You should know at least how to look into these. This is a Q function distribution, and Q function. See, the summary of the things what I have discussed till now is complementary error function. You can able to get the value using error function, or you can get the even the error function value from complementary error function. The sum of these two will be equals to 1. In other words, 1 minus error function of x is equals to complementary error function of x, ERFC of x. Okay. Next, error function ERF of x is linked to the cumulative distribution function. Okay, whereas the complementary error function is linked to the right tail property, that is q function of x. Actually, the terminology q function of x is repeatedly used in the textbook SMK, and whereas this error function concepts were used in a HIP-NSTL. Okay, so to not to get confused, I have just given these things. Actually, this is the q function distribution. Okay, so remember that thing. Now let us try to take a problem. Let us continue the previous problem actually. So once the probability of false alarm is given, we can able to define the value of threshold here, and we found that the threshold value is gamma. Once the threshold value gamma is defined, then you can able to calculate probability density function, probability of detection. Probability of detection is equals to I would like to calculate the right tail probability of this particular function, probability of y given 1. So that means I would like to say one thing. Let me rewrite it once again if you are a little bit confused. Okay, now we are going to have something like this. This is for a single sample case. Okay, this is probability of y given h0, and this is probability of y given h1, and somehow the gamma is fixed. That means the probability of false alarm is fixed. So let this be a probability of false alarm, and as I have indicated, let me do it with this. So this yellow shaded version, yeah, I believe it is not working. Yeah, this yellow shaded version, whatever you are going to see over here, it is nothing but the probability of false alarm. And by using the Q function distribution, we have found that for having this 10 to the power of minus 3, which is equals to probability of false alarm, we should have this gamma value as 3, and this is this we have identified. Now I would like to calculate the area under this curve. That means now for this particular case, Q of gamma minus mu by sigma. Q of gamma minus mu by sigma. Okay, so Q of gamma minus mu by sigma is equals to you are supposed to submit the gamma value 3 in this integration. If I try to calculate it, integral, yeah, where is this? Right till probability. What happened to this here? Let me close this and open once again. Yeah. Now I would like to calculate the area under this curve. Right till probability I would like to calculate. So the right till probability, if you would like to calculate, you should do one thing here. So here, right till probability should do over here. So here, actually, this one will be giving you the area under the curve. Gamma minus mu divided by sigma to infinity. Gamma minus mu divided by sigma. So that means we would like to calculate this one. So gamma minus mu divided by sigma, which is equals to gamma is, we have found it as 3. 3 minus mu. What is the mean over here? If I try to remember, the mean is what will be the mean over here for single sample case? 1. Is the mean value 1?
It is 0, sir. 0. Normal distribution.
Now for the second curve, I'm asking.
1, sir.
Yeah, I think it is 1. For the second curve, if you try to see this here, this is what I'm talking about. So it is 1. So 3 minus 1 divided by, what is the value of sigma? Sigma is also 1 if I'm not wrong, right? Sigma, you see, this is the standard deviation that you are going to have. So the sigma value is also 1. So if I try to calculate this one, you'll be getting 2. That means Q of 2 you should calculate. If you calculate Q of 2, then you will be getting this area. The shade, this area. So that value, if I'm not wrong, that value is already calculated and was found it as, did I written this? Probability of detection. Yeah, the probability of detection, it will be, I'll try to calculate it for you if you required. It will be 0.023. 0. is equals to, so probability of detection is equals to 0.023. Let us check whether our analysis is right or wrong. 0.023. So Q of x, if I would like to calculate, I should follow this. Am I right? 0.023, right? So you try to see, I just changed the argument over here too. Okay. So what I mean to say over here is, this is probability of detection. See, because I tried to calculate the area under the second curve based on the value that I have obtained from the first curve. Is the things clear? Any queries? If you have, please ask me.
No, sir. I am not understanding.
You are not understanding. Okay. See, at least in the last class, we calculated the probability of false alarm. Probability of false alarm is given to you, right? So which is 10 to the power of -3. Right? Shiv Shankar Reddy.
Sir, right.
Probability of false alarm is given. So from this probability of false alarm, how to calculate the value of gamma? So that is the first one. That means what value of the value gamma will gives me the probability of false alarm. So this you can able to do it using MATLAB and using the distribution chart that was given. So if I try to follow the distribution chart, so I would like to have the probability of false alarm 0.001. So the value is somewhere over here. This is the Q function. Actually, this probability of false alarm we can able to calculate using the right tail probability. So with right tail probability, if you try to calculate it, that itself will be giving you the probability of false alarm. What value of gamma will gives me the right tail probability value 10 to the power of -3. So this probability of, yeah.
Why are you taking gamma? If you know the PDF of the both functions, we can easily identify the threshold voltage. Why are you going to gamma value?
So I'll answer your question. Right tail probability. So since if you know the probability density function py of this probability density function, yeah, you can able to calculate this gamma very easily. How to calculate this? So integral gamma to infinity. So if I try to calculate, use this function exponential of minus y square by 2, of course 1 by root 2 pi is equals to 10 to the power of -3. Am I right, Shiv Shankar Reddy? This is the equation that you are going to have. Am I right or wrong?
I don't know, sir.
What you don't know? You see, what you are
Where
saying? Yeah, what is your problem? Tell me.
where are you taken from this equation, sir? I know the probability of false alarm. I don't know the right left hand side part.
So probability of false alarm, how you will calculate? You tell me.
Using gamma value, sir.
See, probability of false alarm, if you would like to calculate, you should
Using
calculate the area under this curve after this gamma. Some value of gamma, at some value of gamma, you'll be getting the area 10 to the power minus 3. So I would like to calculate the value of gamma. Gamma value, I don't know.
Okay, sir.
So to calculate that gamma, we are going to use these distributions. So this is the probabilities. All these are probabilities. So what value of the probability that we are going to have? 0.001. So the corresponding x value, the right tail probability gamma value will be 2.99, which is more or less equivalent to 3. So that means we identified the gamma as 3.
Okay, sir.
So the same thing you can able to obtain using the MATLAB command that was given over here. So the MATLAB command will be, if I am not wrong, yeah, this one. Inverse error function of 1 minus 2x in square root of 2. So if you have a little bit mathematical analysis, you will be getting this value. So for that matter, this will be giving you the value of 3.09. Okay. So our ultimate aim over here to go for either Q distribution or MATLAB. These are the two methods how to calculate gamma value 3. So I want to know what is the value of gamma that will gives me the probability of false alarm 0.001. So now I identified it as 3. Okay. Now, for this value of gamma, what is the probability of detection? I would like to identify. What is the probability of detection for this value of gamma? So for that, you are supposed to integrate the second curve. You are supposed to integrate the second curve from gamma to infinity. That will gives you the probability of detection. Okay.
Okay, sir.
So for that, what we are going to use is, we are going to use again the Q function. But Q function, the actual equation, Q function equation, if you try to remember, Q of gamma is equals to integral gamma to infinity exponential of minus y square by 2 into dy. This is the Q function. That means Q function will gives you the right tail probability for a Gaussian distribution with y follows the normal distribution with mean 0 and variance 1. But now for the second term, means come fast here. Yeah. For the second curve, the mean is not 0. That means I cannot use this straight away this equation. So instead, what I'm going to use, I'll try to use Q of gamma minus mu divided by sigma. So for a random variable x, which has the distribution, which follows the normal distribution with mean mu and variance sigma square, for that the right tail probability can be obtained from this equation, and integral this whole term gamma minus mu divided by sigma to infinity. This term you can able to have it over here. Okay, now whatever the value you are going to obtain over here, the area you have to substitute. That means here actually the gamma is 3. So 3 minus 1 divided by 1 should be our lower limit here. So that will gives you the area of the probability of detection, area of right tail probability, that is probability of detection 0.023. So this is for the mathematical analysis. See, whatever the discussion that we had till now, it will helps you to solve the problems. There is nothing to do with the concept of detection theory over here. So if you want to calculate gamma using distribution tables and using MATLAB, how to do that thing. So for that only I have given these things. Okay, anyway, let me go back to our actual discussion. I hope you people got at least some idea. Still, if you have any difficulty in understanding, please let me know, or please contact me later. Okay. For the timing, what I would like to say is, okay, in Neyman-Pearson method, okay, let me come to the fresh discussion. In Neyman-Pearson method, why I have got this one? Oh, yeah. Okay, I would like to have this thing. So in Neyman-Pearson method, so as we have discussed, we neither require a priori probabilities, we don't want this, and even we don't want cost functions. but some parameter has to be given, that is the probability of false alarm. Once probability of false alarm is provided to you, what will happen is we are going to define the gamma. And if you try to remember yesterday's discussion, likelihood ratio L of y which is equals to, come fast, yeah, likelihood ratio L of y, oh my god, is equals to probability of y given h1 divided by probability of y given h naught, and this should be less than or equals to some lambda. If you try to remember, this is the Lagrange's multiplier in yesterday's class. And this is your h naught. This is the decision what we have obtained in the last class, if you try to remember. And this value of lambda we will be getting from the constant probability of false alarm. Okay. So from the example what we have seen just now, what we have observed is, once probability of false alarm is fixed, then it is going to fix your threshold gamma. Once gamma is fixed, then your probability of detection also fixed. So for the probability of false alarm equals to 10 to the power of -3, we have seen that the probability of detection is 0.002, 0.0023. 0.0023. This is the probability of detection. So once you fix this probability of false alarm, means your probability of detection is also fixed. So that means very small value you are going to have. So in the last class we stopped at this particular point. Even though it is going to have a very low, actually this is not a good detector, because the probability of detection is very small. Because the probability of detection is very small, this is not a good detector as of now. So but still people are using this probability Neyman Pearson detector for radar, particularly in radar applications. So why? So that we will try to see it now. So let us try to take one example again, and then two examples I'll try to use. So now the time is 12:48. I would like to complete two examples now. Okay, two examples I would like to do it, and I want you people to be a little bit more attentive. More or less it will be in the similar lines of the things what we have seen in the previous class examples. So now example 3.2. Before going to example 3.2, I just want to have one more example. Yeah, example. Yeah, please. So let us try to solve one example now. Let us try to solve one example. Come on, yeah. Yeah, example 3.1 from SMK. Example 3.1 from SMK. I really don't understand why it is getting delayed here. Okay. Students, please be very attentive. The problem is similar to that of the things what we have discussed till now. Okay. So probability of false alarm is given as 10 to the power of yeah, I'll do one thing. Yeah, why is this one slow today? It is. Yeah, if you have any queries, please ask me. Continuing the previous example, as per NP detector criteria, we are going to have L of y which is equals to probability of y given h1 divided by probability of y given h0. So for the previous example, this will be 1 upon root 2 pi. Sigma square is 1 exponential of minus y minus 1 whole square by 2. This will be your numerator, this equation, divided by 1 upon root 2 pi exponential of minus y square by 2 less than greater than this is lambda, and this is h naught and this is h1. Yeah, students, is this equation clear to you? మీకు అర్థమైందండి ఈ ఈక్వేషన్? స్టూడెంట్స్, is the equation is
Sir, clear, sir.
okay, thank you. So these two will get cancelled, so you'll be getting exponential of minus 1 by 2 times, so y square plus 1 minus 2y. So I believe if this comes up, if I try to take minus common, I believe here I should have minus y square, if I'm not wrong, minus y square lambda. So these two will get cancelled. So exponential of so minus 1 by 2 y minus 1 by 2 will be there, less than, and this lambda I will be considering it as exponential of some beta. So the lambda is equals to exponential of beta. So this implies y is equals to beta plus 1, which is equals to natural logarithm of lambda plus 1. This is the expression that we are going to have. 1 by 2, right? Someone trying to say this thing. Thank you. Okay, now Akila, is Neyman Pearson detector good detector or not?
No, sir.
Huh?
No, sir.
Why?
Probability of detection is
Probability of detection is
very low.
very less, because probability of false alarm, once you fix it, so the threshold value gamma will be fixed, and hence you will be having the very less probability of detection. For suppose very fine, because probability of detection is very less, that's what told by Akila. So what I'll try to do is, yeah, two curves I'll try to consider like this. So gamma will be somewhere over here. Okay, fine. Akila, you would like to have good probability of detection, right? So for that, what I'll try to do anyway, probability of false alarm is the one which you are going to fix it. So probability of false alarm, if you fix it, then based on that, probability of detection will be there. Now, can I move this threshold to left side? So that, of course, probability of false alarm will increases, but probability of detection also will increases, right?
By varying
Now, if I try to move this gamma to the left side, what will happen is probability of detection obviously will increase, but that will also increase the probability of false alarm. That is not actually the appropriate solution. So now what I'll try to do is, instead of in the example what we have seen now, we have taken only the one sample per symbol. Let us try to increase the number of samples here, and that is the problem that was given in example 3.2 of SMK, and that's what we are going to do it now. I want you people to be very much attentive while solving this problem. Okay, so so now what we are going to do is, instead of considering a single sample, we are going to have multiple samples, and we are going to have multiple samples in NP detector. Okay, the problem is from hip and steel. Okay, so let me take the actual problem 4.16. So after this problem, we will be closing today's lecture. Please don't make a don't think otherwise. 4.16. Okay, the problem goes like this. Under no signal condition, actually this is linked to problem 1.5. Example 4.15 and 4.16. Were these problems given to you for the assignment? 4.1516, not given, right? Okay. Fine. స్టూడెంట్స్ ఉన్నారండి? కొంచెం మాట్లాడండి, నాకేం అర్థం కావట్లేదు. ఈరోజు ఏదో కన్ఫ్యూజ్ చేసినట్లున్నా. ఐ థింక్ సురేష్, థ్యాంక్ యూ. Okay, under no signal condition, only noise is received. No signal condition. I really don't understand why this is very slow. No signal condition, only noise is received. Well, under the signal condition, under signal present condition, 1 volt plus noise is received. So no signal means 0. So noise is added here. When signal means source symbol 1, signal, and you are going to receive 1 plus noise. And he tried to say about this noise. Noise follows Gaussian distribution with the 0 mean and unit variance. 0 mean and 1 variance. We want to design a constant false alarm detector. The other name for NP detector, Neyman Pearson detector, is constant false alarm detector. CFAR. Constant false alarm detector. So you are asked to design a constant false alarm detector now. Constant false alarm detector with probability of false alarm. As the name indicates, is a constant false alarm detector with the probability of false alarm. Probability of false alarm is equals to 0.1. ఓకే చేయండి, ఒక 1 minute లో చేసేయండి ప్రాబ్లం. మీకు ఏమైనా వాల్యూస్ కావాలంటే డిస్ట్రిబ్యూషన్ టేబుల్ ఓపెన్ చేసి రెడీగా పెడతాను. వాట్ ఎవర్ యూ వుడ్ లైక్ టు హ్యావ్ యూ కెన్ ఆస్క్ మీ. సో డిజైన్ ఎ కాన్స్టెంట్ ఫాల్స్ అలారం డిటెక్టర్ విత్ ద గివెన్ ఇన్ఫర్మేషన్. Question ఎవరికైనా, if anyone doesn't understand the question, please let me know. Or if you don't know how to solve the problem also, please let me know. And if any data is required in between, that also you can ask me. (0.1). If you want me to open that, I can open it. Yeah. So probability of false alarm is 0.1, right? So probability of false alarm is 0.1 means I believe it is somewhere over here.
1.28.
1.28 you can take if you want. 1.29 also you can take. Because in here it is taken 1.29, you take it 1.29. 1.29. Were all students following the problem or not? So those people who have completed solving this problem, you can please let me know the answer. I would like you to detect a constant false alarm rate detector or NP detector. I came to know that MTech people were might be asked to come to the college from 1st November, if I'm not wrong. So be prepared for that. Suresh, చెప్పండి. 0 point. What is that 0.28? Probability of detection. 0.38 is probability of detection. Fine. So what is the threshold? 1.2. Okay, fine. Yeah, students. Suresh, can you please share your snapshot?
Hello.
Could you please share your screenshot of the things what you have done? Suresh.
Hello. Yes, sir.
Could you please share screenshot of the things what you have done?
Yes, sir.
So probability of detection is equals to how much? Once you are asked to find out the designer detector means your receiver sample should be y and what value this has to be compared so that I'll take the appropriate decision. So this, if you tell that itself will be sufficient. And I came to know that this value is, Susan, what is this value? Right side value?
Sir, which one, sir?
This one.
Which one, sir?
Oh my god. Yeah, this one. The circle one.
ln of lambda plus 1 by 2, sir.
Ln of lambda plus 1 by 2. What is lambda, sir? What is lambda, sir?
Lagrange's multiplier, sir.
Now find it out and let me know what is the actual value. For that, you may be required to use this. Suresh, I think I asked you to share. Those people who completed, can you please share it with me? Those people who completed, could you please share your documents with me? ఏమండి మీరు షేర్ చేయండి త్వరగా టైం అయిపోతుంది వీ హ్యావ్ టేకెన్ ఆల్ ఎక్స్ట్రా 8 minutes now. I want you to take another. Yes, someone has shared. ఇది ఎవరిదండి? సురేష్. సురేష్. పెయింట్ ఎక్కడ నుంచి వస్తుందండి?
Sir, value of lambda is 2.23, sir.
Value of?
Lambda is 2.23.
So ultimately, what is the threshold?
I don't know, sir, that is correct or not.
మీరు షేర్ చేశారా? మీరు చేశారండి? మీరు చేసింది నాకు స్క్రీన్ షేర్ చేయండి. ఫోన్ లేదా? చేయండి అబ్బా, మీరు ఎందుకు అంత అలా చేస్తున్నారు? మీరు ఏం చేశారో చేయండి అమ్మా నాయన. సరే నేనే చేస్తాను చూడండి. సో ఇఫ్ ఐఎమ్ నాట్ రాంగ్, ఇక్కడ ఏం లేదండి, మీరు ఇంత కష్టపడాల్సిందే. సో ప్రాబిలిటీ ఆఫ్ false alarm is equals to 0.1 ఇచ్చారు. That is sufficient. So what value of gamma will gives me the probability of false alarm? 0.1. So from that you can able to make y should be less than greater than h naught h1, and I believe this is 1.29. And hence this is what I expect. Designing a detector means this is what the detector is. And if I try to follow the probability of detection is equals to 0.38
Yes, sir.
0.3859. ఏమైనా డౌట్స్ ఉన్నాయండి ఈ ప్రాబ్లంలో ఇప్పుడు దాకా? If you like to go with reference to the conventional method, so we should know what is ln of lambda. So ln of lambda, this lambda is a parameter that we are going to calculate from the probability of false alarm. Okay, so from the probability of false alarm means this is what the gamma that you are going to have. Okay, so here actually this is what we, ln of lambda plus 1/2 should be equals to the threshold what you are going to get over here. And for 0.1 it was found that 1.29. So it's not required to calculate ln of lambda now here. Suresh, are you getting what I'm saying?
Yes, sir.
All here and okay, now the time is 13:13. I will give 1 minute time. If you have any queries, you can ask. 13:14 tak you can ask. You can ask up to 13:14. Please, I'll be going for the extension of this problem. If you don't understand this, the next problem may be a little bit difficult to you people. Threshold. Yeah, you can calculate the lambda. That's not a big issue, but it's not required to calculate lambda and all those things because you are getting the threshold straight away from the probability of false alarm. See, here, this is actually the threshold that we are going to have. My God. See, in this particular equation, natural logarithm of lambda plus 1/2, this is not required to calculate. It is not required because you are going to get this whole threshold value straight away from your probability of false alarm. So whatever the gamma value that you are going to have straight away, you can replace this whole term with that gamma. And that is the parameter what we are going to use to take the decision. And hence that is the reason why I told you that this is my detector. CFAR detector. Okay, now let me continue with the problem. Suppose that we have same condition as in this example, except that we have access to 100 samples. Now the samples were, number of samples were 100. So if number of samples were 100, then what will be the detector? If number of samples were 100, what is the CFAR detector and what is the probability of detection? This is the question. Do it. If you have any questions, you can ask. See, if anyone has the tablet or some iPad, something like that, and where you are trying to do it on your screen, could you please share that so that we will follow it? ఎవరు ఏం చేయరు కదా ఓకే నేను చెప్తాను చూడండి I'll be very happy if someone of you gives me the answer. Okay, how many of you want me to explain this problem? Could you please raise your hands or at least type in your chat box? How many of you would like me to explain this problem?
Sir, I want.
Shivashankar Reddy. ఏమండి బాబు నెక్స్ట్
Sir, I want.
సురేష్
Yes, sir.
okay all the people I think you can able to calculate L of I, right? L of I you can able to calculate, right? I want all of you to calculate the expression for L of Y for 100 samples case. I believe this is not a big task for you. Shivashankar Reddy, can you do this? I want you to calculate the expression for L of Y for 100 samples case. This I believe you people can do it very easily. Am I right or wrong? Shivashankar Reddy, మాట్లాడండి అబ్బా.
Sir.
Can you calculate L of Y?
Yes, sir. I will calculate.
Do it and tell me what is the final expression that you have obtained. Yeah, those people who gives the answer first, for them I'll be giving some surprise. Those people who gives me the answer, I'll give some surprise to you. It already this one I think you people have already done it.
Sir, exponential of -50.
Share your screens. Send me the snapshot of the last expression that you have obtained.
Okay, sir.
Yeah, waiting for the answer. మీరు కూడా అండి. You also can share it with me. I'm expecting something from you people. Yeah, someone has given me the answer. Let me cross check it with the one which I had so that I can. So exponential of -50 plus summation I is equals to, yeah. Okay, my dear friend, ఎవరండి ఇచ్చింది ఇది? So actually L of y is equals to, as was obtained over here. Let me take red, which I used to have.
Sir,
Okay.
L of y equal to e power. L of y equal to
Is my screen visible to you?
Yes, sir.
Yes, visible, sir.
Who gave this? I mean, this document. Who sent this document?
Chiranjeevi, sir.
Chiranjeevi. Thank you.
Yes, sir.
Yi, and if I am not wrong, this is lambda, right? And of course, this is h naught, and this is h1. I would like to select this as it is. Copy. I would like to paste it over here. Control V. Yeah. Chiranjeevi has given me this equation, right? So let's go ahead with this equation. So let me apply natural logarithm to both sides. So minus 50.
before
Huh?
before nothing.
అబ్బా సరిగ్గా చెప్పండి అబ్బా, బిఫోర్ అని అంటారు, ఏంటో మ్యాటర్ చెప్పకుండా చెప్పండి. వాట్ ఈస్ ద ప్రాబ్లం? Okay, now this is my new variable, new random variable. Summation of y is equals 0 to 99. Yi is my new random variable. So let me assume that this new random variable as, and let me assume this is my threshold gamma. Okay, so this is z gamma h naught h. Okay, I want you people to draw the probability density functions of this z. Z when h naught has been transmitted, and z when h1 has been transmitted. Could you please draw it? Here z is a summation of 100 random variables, y0 to y99. So I want you to draw the probabilities of z, probability of z when in other words, what I want you people to draw is probability of z when h naught has been occurred, probability of z when h1 has been occurred. So can you please draw this? So what are the modifications or differences that you are going to have? Let's try to have a look on this. Oh my god, this is very slow, yeah, Microsoft. Okay, so for the case 1, I would like to plot probability of z when h naught. So 100 samples were there. What will be the mean value for this? Of course, mean will be 0 and variance will be
100, sir.
100. So I'll be having variance will be 100. So that is the reason why. So this is this one. For the second case, mean will be 100 into 1, right? Am I right?
Yes, sir.
So you are going to have mean value 100 here, and hence So this is 100. Okay, the spread is more now. Now the given probability of false alarm is 0.1. Probability of false alarm is 0.1. Now you are supposed to find out the value of gamma. So in earlier case, we are going to have the curve something like this. So mean 0 and variance 1, something like this. And of course, for the second case, mean 0 and variance. And this is what you are going to have in the single sample case. Okay. Now, we would like to calculate the value of gamma that will gives me the probability of false alarm. Gamma is equal to how much for the probability of false alarm is equals to 0.1. So that means Q of gamma minus mu by sigma should be equals to 0.1. Okay. So what value will give? Last time when we tried to calculate this whole term should be equals to, that means gamma minus mu by sigma should be equals to 1.29. That's what we have observed in the previous case.
1.29, sir.
Yeah, this is what we have observed last time, right? So now mean is 0 and variance is 100 now for this particular case. For this variance is 100 for this curve. So that is the reason why you are going to have gamma is equals to 1.29 multiplied with 100, 129. Am I right or wrong?
Yes, sir.
So if gamma is 129, I believe this is sigma is variance, that should be 12.9. It should be 12.9. Do you agree with this point? Here sigma square is 100. The variance is 100 for this curve. For this curve, sigma square is 100. Oh my God, I should have closed this before. Yeah. Sigma square is equals to 100 and hence sigma is 10. So you'll be having gamma is equals to 12.9. So when gamma is equals to 12.9, then you are going to have the probability of false alarm as 0.1. So when gamma is equals to 12.9, what is your probability of detection? Probability of detection is equals to, it is also the right tail probability, Q of gamma minus mu by sigma. So now we have defined the gamma value as 12.9. So Q of 12.9 minus gamma value, mu value is 100, right? Mu value is 100.
Sorry, here is variance is the n sigma square, sir. That means 100 into 1. Sigma square is 100. Sigma is equal to root 100 equal to 10.
So what is the problem?
For taken 12.9.
See, sigma is 10. So if I try 1.29 multiplied with 10 will be 12.9 only, right?
Yes, sir.
Huh?
Yeah, yes, sir. Okay.
So 12.9 minus 100 divided by sigma. Sigma is again equals to 10. So if I try to calculate this value, this will be something around Q of ఎక్కడండి 100 minus 12 will be something around 86. 8 point? Forget about that minus or plus, because Q function is a positive value. It will take always the arguments, this one. So Q of 8.7, if I try to calculate, how to calculate Q of 8.7? Q of 8.7, let us look into this if it is available. ACSP. Q of 8 point, it is not available here. So Q of 8 point, I believe it is available here. 8 point. Oh my God. Okay, I should use this. 8.7 means Q of 8.7. You see here, people. See, I tried to calculate Q of minus 8.7. 0.5 into complementary error function of minus 8.7 square root under square root. So this goes to 1, which indicates that my probability of detection in this particular case is equals to plus 1. What I have used? 1 by 2 times complementary error function of x by root 2. So in place of x, I have kept minus 8.71. And if I do the same thing over here, 8.7. I'll be getting. So Susan, could you please conclude what we have discussed now so far?
Yes, sir. In today's class, we discussed about the complementary error function, Q function, and complementary function, sir. And then we solved the previous, the example which we have solved in previous class. And then we found out the decision rule for the sum that was discussed in the previous class, and then we considered the case of the multiple samples.
Yeah, from this, the example what we have done, what can be concluded? So initially, what for single sample case, what is the conclusion that we have drawn about NP detector?
Probability of detection is lesser, but here the probability of detection increased to 1, sir,
Increase
in
it to.
case of multiple samples.
So can we use NP detector now?
Yes, sir.
Because the probability of detection is equals to 1. We have taken, we just increased the number of samples to 100. That's it. In the case of single sample case, we have obtained that the probability of detection is 0.028, which is very, very small. The moment when I increase the number of samples, then the probability of detection has been gone to 1. That means exactly I can able to detect the target without any chance of losing it. So because of this reason, NP detector, Neyman Pearson detector or constant false alarm rate detector is one of the important detector that was used practically, that is being used practically in real-time situations. Okay, with this I would like to conclude. If you have any queries, you can ask me. I believe the silence means no queries. I can stop recording now and then I can end the lecture.